to everyone. Here is CJ, and today also we have to solve the some legal problem together, and the topic is also flying to rotated 75. And today's topic is 39 combination sum. And let's start with the topic, but before that, this level is median, and the topic is about the combination. Given an array distinct integer candidate and the target integer target. Okay, so we got the first group is we got a list of the integer, and each integer is distinct, is different. And then we got a target integer, which is also integer, and we have to return a list of combination of candidates, and which the sum chosen number sum the target. That's it. Is we should use the number in the candidate and make it sum, and let's put those combination which is matched with target into the list. So our output is a list with the different kind of the combination which sum is matched with the target. And also we have the second clue. The same number may be chosen from candidate an unlimited number of times, which means in the combination we can use each element, each integer many times. For example, like here, the target is 7, so we can use 2 times of 2 plus 1 time of 3 to make it become the 7. And 7 is equal to 7, so in our output should be a list with 2 combination 2 to 3 and 7. Okay, so let us start. So firstly, since it is the topic about the combinations, and also we choose each element and decide it is used or not, and then we have to make it with the different kind of combination. So I think this topic is about the backtracking and also use the recursion to keep going to search with the different kind of number and combine with the different kind of integer. And since our output is this, so we can put it first. We can put a list of result, and then we can put every possible combination which is suited with the target into our result. And we should have a function find all combination, and then in the recursion we need the first best case is if total if the sum of the number is equal to the target. We should stop and put this combination into result. And then the second best case should be if total is bigger than target. We should also stop, and also if index, because we will try to use the index to control the candidate we will use in that time. So index will keep +1 +1 and keep bigger. So we have to control index will not bigger than the length of the candidate. The length of candidate minus 1. We just make sure the index will not bigger than the last number of last index. For example, like here we got the last index is 3, so we just make sure the index well smaller or should be bigger. We should stop if the index is bigger than the last index. So we can start with our logic here. So first logic, we should put the candidate into the list, and then put put that, and then start recursion. So start find combination. We call it find combination, and we need firstly is the index to control the candidate, and then the second one. So the second one is the combination, the sub combination. We will put the candidate into the sub combination, and then its total is which we will use it to compare with the target number. So here, if total equal to target, we will put it into our result. We will put the sub combination into result. But here we can put it directly into the result because without the sub combination is a reference. It's point to the part of our memory. So it's not a value direct. So we should change it to the value so we can use the slides to just copy this number. And then it, the second best case is total bigger than in that part we should return we just start here. And then so we got two best case to stop our recursion and then stop our logic. So our sub combination should be a pen, should be a pen, the number we will candidate we focus this time, so we just use index to focus on the candidate we want to deal with this time and put everything into our equation again. So index and then sub combination and total should be plus with the candidate, right? And before we keep going, maybe I would like to put first call our function first. So with this function, we start with the index 0 and an empty list, and total is 0. And then in the result, we should return our result, right? Result list, right, as output. Okay, so we can keep going. So with these two parts, we can put the numbers into we put each candidate into the two best case to check is equal or bigger or anything else. But if, for example, like 2 plus 2 plus 2 plus 2 is 8 and it's not equal but it's bigger, so we will stop here. So now we will start backtracking here, which means the top we will backtracking, which means we should remove the last element, last integer, and then put the next integer into the function. So in that we plus 1 because we will use the next integer as the element of the combination, and sub combination can keep it and total can keep it, because when we put this new index into our function, in here we will use the new index. For example, like here 0 plus 1, we will put 1 with index 1, which is the number 3, and put index 1 and 3 into our function, and then check if the total is equal to target or not. Okay, same example. So we have a quite good complexity. For the time complexity, it's all of 2n times, which means that each selection you can choose use it or not, and the n is depending on the target, which means is the biggest number. So for example, like 7, target is 7, so the n basically is maximum is 7, because the number is not possible bigger than 7. So you can have every possibility to use this number or not, this number or not, so to n time. And then the memory is about, the first thing is the result. The result is k multiple m, o k multiple m, which means the length of each sub-combination and how many sub-combination in the list. And also we use the recursion here. So the other recursion is, so the depth of the recursion is depending on the target, which means how many number we will go through to the target. So we will go how many times is the depth of the recursion depending on the target. And I would like to change a little bit about, modify a little bit about the explanation about time complexity. The time complexity 2n time should be by the number here. Depending on the length of N is the length of the candidate because it depending on how many number of years. So the 4 years, normally it's 4 times like that because you can choose it, use it or not, use it or not, use it or not. That's all. Thank you very much and have a great night.